While using Google Maps, have you ever wondered how it is giving customized and best routes depending upon our requirement and the traffic pattern which changes rapidly around us? Or you might have noticed that the link suggestions that we get in any kind of social media platforms like LinkedIn are depending upon our previous connections and the connections that we are being in. What might be the reason behind this? The main factor which is playing a vital role here is persistent graph data structure. Hi there, I'm Harshavardhan. In this video, I'm going to explain you about the concept of persistent graph data structure. So without any further delay, let's get into the video. Before going to the core concept, let us have a glimpse about the concept persistence. What is persistence? Persistence is nothing but the ability of the data structure to store its previous versions and give accessibility to them. There are three kinds of persistence. Primarily, partial persistence, where you can just access the previous versions but cannot modify them. Just like your bank transactions, where you can just see the previous transactions but cannot modify them. Next comes the full persistence, where you will have both the features mutability and accessibility. Just like your Google Documents, where you can just access the original version, at the same time, you can modify a copy of it. Finally, confident persistence, in which a new version is generated by branching the previous versions. Just like in Git version control, the developers branches the previous versions to generate a new version. Now we will be seeing some of the applications of persistent concept in daily life. Persistence is very valuable in the cases where we need to record and analyze the data changes. Here comes the version control where it will track the changes that are happening to the file. Temporal databases will maintain the historical records of the data sets in the previous versions. Undo operations are used in the text editing and many more applications where we need to access the previous mode in order to make the modification in the original version. Finally, simulation and game states where we will be coming across the previous strategies that we have used, just like a checker games or chessboard, where we will be knowing the previous move that we have used for the further strategies. We are entering the core concept now. Here, the concepts that we are going to discuss are being exhibited. First, we will go through the intro. In sense, we will know what is persistent graph. Then we will be seeing key characteristics. Later, we will know the techniques, then applications, and the challenges that we face. Finally, we will have a summary in a nutshell. Persistent graph. A persistent graph is a graph data structure which allows access to its previous versions even after being modified. Unlike the ephemeral graph data structures, persistent data graph structure allows the changes over the time and records them for providing the accessibility and controlling the multiple versions over the time. So, what makes persistent graph unique? Well, there are mainly three traits which makes it unique. First one is historical access, where you can access to any of its previous versions in order to know what happened then in the data structure. Next, immutability in modifications. Instead of changing all the graph nodes, we can just copy the changes that we have done in order to save the memory. This would be helpful for memory management. Finally, efficient updates and storage. Persistent graphs use several techniques like path copying and fact nodes and immutability data structures in order to avoid unnecessary duplications, which will help in memory efficiency. Now we will be looking into the techniques that to implement data structure. Path copying, where only the paths that are affected by a change are duplicated for efficient memory management. Next comes the fat nodes, where each modification done to the particular node is going to be stored in the persistent nodes. Next, finally, we will see immutability structure where the original form of the graph is stored and the copies are gone through the modification, which will allow us to access any kind of previous version since they are not modified. All right. Now we are looking into the applications of persistent graphs. Firstly, version control system. Persistent graph allows users to access the previous versions and merge those previous versions to give a new version. This is known as version control system. Then comes the temporal databases, which is largely applicable in financial sector, healthcare, and CRM databases, where changing the records is frequent and storing them is crucial. Then comes the social networking and communication networks, where persistent graphs tracks all the evolutions of the relationships and interactions that we have gone through in the net platform, any kind of platform like LinkedIn. Let us take an example. The connection suggestions that we get are depending upon the connections that we are being in or the environment that we are being in. Next, GIS and road network evolution, geographical information systems and mapping services like Google Maps that we see, which will give a specific path when we require to go to a certain destination, depending upon the patterns, depending upon our time that we need to reach there and our facilities, the mode of travel, all these factors are considered. These are taken into consideration by GIS and road network evolution, which will give us a customized solution for our query. Then comes the simulation and game development. All the rewind sessions or the undo steps that we take in games are depending upon persistent graph only. In simulation, persistent graphs can help analyze decision making that we have done so that we can predict the upcoming strategies. Now we are going to the depths of the concept. First, we will just see the applications. The first one is version control systems. Usually, these are used by developers when they need to access the previous code in order to create a new version by combining those previous versions. How the persistent graph helps in this? When we take the example of GitHub, each change that we have done will be represented as a node, and the branch or merge that we have done will be represented as a edge for that. It allows users to access any kind of previous versions on the code basis particularly and create branches from any commit or any merge that we have done. This enables collaborative coding, capabilities, and clear tracking of the development history. What is the benefit that we are going to get is it ensures the data integrity by preserving each stage and allowing a full navigability history that supports collaborative development and detailed accountability. Here comes the temporal databases. These are largely used in financial, health, and customer relation management sectors. It would be critical to store all the changes that have happened because in these sectors, particularly, there will be numerous modifications. When we take examples of financial sectors, the accounts that stocks that change are rapid and daily also. And when we take the example of health sector, the patient's condition will change day by day. So we need to record all the changes to make analysis and further predictions. It would be difficult for us to store all this. So in this cases, we use persistent graphs. And how we use them? When we take when the term temporal databases allows us time-based queries. For instance, if I want to know the value of the stock that was there on particular date, we can access that date by this temporal graph and we can see the price of the cost at then. When we come to the health sector, we can know the patient's condition then at the time when we want to know, like when we have admitted him, what was his state after giving medication, what was his state after the operation, what was his state. So like this, we can make the analysis and give particular medicine or drug or the treatment that we want, which is helping the doctors in the health sector a lot. So we can, what we do is that it will just attach a time stamp or the version number to the particular data so that we can access to that time and when we can do our work. And the benefit, as I mentioned before, allows the historical needs and generates time-based report, which will assist us a lot, and this has immutability so that we can know what was exact condition at that time. I let it be stock or the patient, so that we can make accurate predictions. In several social media platforms like Facebook, LinkedIn, to understand the user's behavior and we use tracking of changes that are happening to his connections, interactions, and engagement. How persistent is used is that each person, each user is considered as a node, and the connection that they are having is considered as the edge. It will allow to track the connection changes that are happening over time and analyze that, and it will know how influencers gain followers and how network clusters form and dissolve. From is this enabling historical insights into social dynamics, which are useful for improving recommendations, algorithms, trends that are going through Insta trends so that it can suggest particular sounds that they use or the script that we want, content, or whatever it will come, the content creation, social influencing, all these things will come under to the benefit of social network analysis. Now, when we say GIS and road network evolution, like geographical information systems and mapping services like Google, need to track the changes rapidly that are happening around and surround the way that we are traveling through, because traffic is a rapid thing that changes. So it need to provide a customized way and a good way. For that, persistent graph is very useful. It enables the storage of different versions of the road networks, allowing the users to view the state of the road right now. Like if I want to go to some other state, how are the roads are there? How what is the way for that destination? How would be the traffic if I go on particular day? Or what is the toll gate cost that I need? All these are suggested because of the GIS and road network evolution, in which this persistent graph is the background. Historical route analysis for the services and as an insurance when where accident might happen. All these are mentioned as I am depicting in the picture. You can see these are taken by persistent graphs only, which will assist the travelers a lot for the toll gate charges or best route times and depending upon our requirement. When we talk about benefits, supports accurate and historical route planning. The facilities that we need a particular place can be informed well before only, and it provides evidence for insurance claims and legal inquiries. Finally comes our favorite game development and simulations. We usually use them in ability to rewind and relive the past days, especially in game strategies. How we have taken the steps and what if we have taken some other step. These kind of scenarios can be encountered with this game development and simulations using persistent graphs. The implementation of persistent graphs in game development and simulations are like it will store the previous state of the game and the versions, and it will set up allows players to rewind the moves that they have taken and explore what if scenarios. Like when we just take example of PUBG or Free Fire, what would be the scenario when we take some other gun or some other destination? What would we hide in some other place? All these kinds will come. And when we take the example of checkers, there we can know what would be the strategy that I might have used there so that my particular coin can be here, or the check that we need to make might have be skipped, or all these kind of things will come under consideration. When we come to the benefits, of course, enhance the player's engagement. We will now only we are involving, and then we will indulge in that. Indulging is different from involvement, right? So we can have even indulgement in the game, and we can dedicate it. We can be dedicated to the game, and it will give a richer experiences, allowing the scenario analysis. Now we will be seeing some of the potential challenges those arise in the scenario of persistent graph data structure. The primary one is memory usage. As I have mentioned in the earlier concept, persistent graphs of course make several versions. Since we need to allocate memory for all of this, if you are failed to manage this memory allocation, definitely it will consume a significant amount of memory. It would be a hectic for us. So we need to be very careful in this memory usage. Then comes the access complexity. Unlike the ephemeral or the non-persistent graphs, where we can access any node just by traversing through that, since it is having a fixed data structure, it would be easy for us. But now in the case of persistent graph, each version may have slightly different data structure. So definitely determining which node and which edge is a hectic one for us. It finally results in a access complexity. And then we can see the performance overhead as it takes lot of versions. Unlike ephemeral graphs, each operation that modifies the graph could potentially affect the paths, nodes, edges, and need to be copied, which will be a performance overhead through the code that we can say. Now we came to the conclusion part. We'll just have a summary in a nutshell. First of all, we have discussed about the concept persistence and the concept of persistent graph, which is a data structure that retains the past versions even after modifying. There are three types of persistence, namely partial, where we can just access the previous versions. Then comes the full persistence, where you can have modification or feature also. Finally, confluent persistence occurs, where you can create a new version by combining two of its previous versions. Then comes the key characteristics, which are historical access, immutability in modifications, and efficient updates and storage. Then we have discussed about the techniques in which these persistent graphs can be implemented. First one is path copying, where the paths in which you have done the modifications are copied. Then comes the fat nodes, where each node stores its modified previous versions. Then the immutability structures will entirely copy the structure and do modification. Then we came across the applications, daily life applications of that, namely version control systems, temporal databases, social network analysis, GIS and road network evaluation, and finally we came across game development and simulations. Before the conclusion, we have seen the challenges, the potential challenges those arise in the concept of persistent graphs that we can say. First one is memory overtake. When we are unable to manage the memory allocation, definitely it will consume a significant amount of memory, which would be a headache for us. Then access complexity is also another challenge that we face. Like it will take a lot of time to access a particular node since we are having multiple versions in the same graph. It would be more specifical when we take the scenario of large graphs. Then comes the performance overhead. Since we are having a lot of versions of the same graph, definitely to access a particular node or particular edge, it will be a complicated process, which would be a overhead for the performance to the process, and it will always be late for us to access the element. Okay, that's all for this video. I hope you got the concept of persistent graph. If at all you have any queries, please do let me in the comment section. For further more videos, do subscribe my channel. Till then, bye bye.